Okay, so we're going to talk about our introduction to angles. So angles. An angle is a figure that's formed by two rays that have the same endpoint. So here we've got two rays. We've got CA and BA. They have the same endpoint. They share the vertex A. So this is an angle because it's two rays, B and A, C and A, and they share the common vertex A. Now, you can name an angle three ways. So you can use the 3 points. The middle letter is always the vertex. So we can name this angle CAB or BAC. Notice I did not label it angle CBA because B is not the center. So the center of the angle has to be what you name it. So CAB or BAC. So the vertex here has to be in the middle of whatever you name it. Now, when there's only one angle at a vertex, then a single letter can be used. So this could be angle A. And a number can also be used if there's a number in the diagram. So this can also be angle 1. Now, how many angles can you find in this angle here? So you should be able to find 3. So we've got angle POS, angle POR, and angle SOR. Now if you notice, the O, or the Q, is in the middle for all 3 angles. That's because it is the center of your angle. So example number 2 says, name angle 1 in 2 different ways. So here's angle 1. We can name it angle ABC, or we can name it angle CBA. Alright, we're going to go down to measures of angles. We're actually going to go to congruent angles. So angles with the same measure are called congruent angles. So angle BAC is congruent to angle DEF. And they're both 50 degrees, and this is how you write it. Angle BAC is congruent or equal to angle DEF. Now, we're going to go over to the angle addition postulate. And this is important. It says, similar to the segment addition postulate except with angles. So our interior point is inside the angle. So if you see, it's labeled with I. So this is the interior of your angle. The exterior is the exterior, which is the outside. So angle E would be your exterior point because it's on the outside of the angle. Now, the angle addition postulate says that if P is the interior of angle RST, then angle RSP plus angle PST has to equal the entire angle, angle RST. And that's because right here we've got ray P bisects angle RST. And when a arrow or when a ray bisects an angle, it cuts it into half. So that means that RSP and PST have to equal the entire angle of RST. So let's look at some examples. So we've got angle ABC here, and it's bisected by ray D. So that means it cuts it into half. But for this point, it doesn't cut it into half, and it actually gives us the measures. So it says that angle ABD is 50 degrees, and angle DBC is 35 degrees. But we're looking for the entire measure. We're looking for ABC. So we have to say that angle ABD, which is 50, plus angle DBC, which is 35, is 85 degrees. So the angle ABC is 85 degrees. Let's go over here. Okay, we've got our straight line, and our straight line is D, E, and F. And the picture tells us that angle the entire angle, because a straight line, is 180 degrees. Now angle D, E, and F is 145 degrees. And it wants us to find the measure of angle D, E, and G. So if we know the entire angle, or the straight line, is 180 degrees, and this measures 145 degrees, we're just going to take 180, we're going to subtract it by 145, and we get 35 degrees. So we can now say that angle DEG is 35 degrees. All right, so let's take a look at the next one. The next one wants us to find the measure of angle DE and G. So if we look here, this is what we just did. So let's look at example number 3. It says find the measure of angle ST and V. So let's look. ST and V is 3x plus 2. And VT and U is 2x plus 8. And both of these, 3x plus 2 and 2x plus 8, is going to equal STU. And it tells us that STU is 160 degrees. So all we are going to do is set it up. So 3x plus 2 plus 2x plus 8 is 160 degrees. Now we're going to combine like terms. So 3x plus 2x is 5x, and then 2 plus 8 is 10, and that equals 160 degrees. We're going to subtract 10 from both sides, and then we get 5x is 150, because 160 minus 10 is 150. We're going to divide both sides by 5 to find our x, and x is 30. Now, if you look, it asks us to find the measure of angle STV. So we found x, and now we need to plug it back into angle STV. So STV is 3x plus 2. So we're going to plug in that 30 for x. So 3 times 30 plus 2. 3 times 30 is 90 plus 2 is 92. So the measure of angle STV is 92 degrees. Okay, now we're going to go through the different types of angles. So there are 4 different ways to classify angles. Number 1 is acute angle. Acute angle is an angle that is less than 90 degrees. The way that you can remember this is someone that's cute is small, so it's less than 90 degrees. Now, number 2 is a right angle. Right angles are always equal to 90 degrees. An obtuse angle is always more than 90 degrees, but less than 180. So an obtuse, if you can remember, obtuse means big, so it's more than 90 degrees. And then a straight angle, which makes a straight line, is 180 degrees. So let's look over here. Example 1 says, the measure of angle A is 10. So is it going to be acute, obtuse, right, or straight? So a measure that equals 10 is going to be acute because it's less than 90 degrees. Look at B. The measure of angle B is 110 degrees. It's going to be obtuse because it's larger than 90 degrees. Now the measure of angle C is 180 degrees, and that forms a straight line. And the measure of angle D is 90 degrees, which forms a right angle. So now let's look at some of these pictures. So if you look at A, this angle here is less than 90 degrees because 90 degrees forms a right angle. And this is less than that right angle. So A is going to be acute. If we look at B, it's greater than 90 degrees. It forms an angle that's greater than, so it's going to be obtuse. And then lastly, C, it forms a right angle, so it's going to be a right angle. Now we're going to look at angle bisectors. So remember what I said before. An angle bisector, so ray DC, cuts angle ACB into half. So we have ACD equals DC CB. Now, adjacent angles share a common vertex and side, but have no common interior points. So if you look here, ACD is adjacent to DCB because they share side CD and they have the common vertex, which is at C. Now our angle bisector, remember, cuts things into half. So let's look at this first example. It says PRQ, PR and S, PRQ, and we've got QR and S, and we're going to solve for X. Now if you remember, an angle bisector, the bisector cuts your angle into half, which means that x plus 40 and 3x minus 20 are equal to each other. So that's the way I set it up. X plus 40 equals 3x minus 20. And now all you're going to do is you're going to combine like terms. So you're going to minus x from both sides, and you get 40 equals 2x minus 20. You're going to add 20 to both sides, and you get 2x equals 60, divide by 2, and x is 30.